Hey everybody, and this is the second installment, second part of 6.6C, section 6C, which is on the normal distribution. And here we're going to be talking about what's known as the standard score, or sometimes called the Z-score. Z-scores and the standard table. All right, and so in your textbook you will see, and in your handout you will see this table, table 6.3, standard scores and percentiles, and percentiles and percentages as far as we're concerned are basically the same idea. All right, we'll talk a little bit more about that in another video about the difference between percentiles and percentages, but just suffice it to say that we're okay thinking of those numbers under the percentile number columns as percentages for most of our stuff. Okay, so again, this table obviously will be given to you, and you just have to know how to read off of it. Okay, but before we can read this table, we have to know how to find this Z-score idea. And so here's the idea of what the Z-score really means. Okay, and so this is my definition of whatever, but the Z-score is the number of sigma, the number of standard deviations a data point is from the mean. Okay, in a normal distribution, obviously we're talking about normal distributions here. Okay, so it's the number of standard deviations. If you remember back to the 68, 95, 99.7 video, we counted by whole standard deviations. If the standard deviation was 20, we counted by 20s. Here, we're going to be able to think of standard deviations, not just whole numbers, but half of a standard deviation or 0.32 of a standard deviation or whatever. And so that's how the Z-score lets us do that. And so the formula for the Z-score, I'm going to give it to you in two forms. All right. If X is your data point, then you want to subtract away the mean. That's how far away from the mean you are. And then you divide by the standard deviation so that you can normalize it out. In other words, if I was one standard deviation away, then when I divided the number distance-wise with the standard deviation, I just get a 1. Okay, and that's what I'm hoping for. And so what this is, again, is this is your data point minus the mean for your standard deviation, for your normal distribution, over the standard deviation. Okay, so that's how you do this formula. Again, I'll give you this formula just like I give you all of them. Okay, but that's how we do it. So let's just do an example here. All right, and so this example is going to take into account a couple of different things. All right, this is just one off the top of my head, but in a normally distributed data set, all right, the mean is 50, and the standard deviation is equal to 5. Okay, so remember, mean is X bar, that's equal to 50, and then the standard deviation is 5. And so a couple of parts here. First thing, find the standard score, all right, or what I will call the Z-score. Find the Z-score of the data value 40. Okay, the data value 40. Well, how do I do that? Again, the formula is take your data point 40 minus the mean 50 all over the standard deviation. So I get -10, the negative again representing that I am less than to the left, or less than the mean, 5, and so I get a -2 as my z-score. Okay, I get a -2 as my z-score. Now, if we draw the normal distribution, okay, and again, just like for the 68, 95, 99.7 rule, I am not going to grade you on the quality of your graph, but I am suggesting strongly that you graph this stuff out so that you know where things are. So 50 is the mean, 40 is somewhere over here, all right, and that is 2 standard deviations away, but it's -2 standard deviations away. Notice if I counted by 5, right, I'd get 45 and then I'd get 40. Notice what my z-score is. My z-score for the value of 40 is -2. Again, what that represents is 2 sigmas to the left of the mean. That's what the standard score represents. It's a standardizing, it's a normalizing of your data set. And so I'm over here, and so if I wanted to find, for part B, I wanted to find the percentage, or the percentile, but find the percentage of data that is less than 40. Where am I? Well, I am, using a different color, I am over here somewhere. All right, I'm looking for all the numbers over here, 30, 32, 37, 12, 6, 1.2. I don't know what these data sets represent. And so the numbers could be anything, but that's the data I'm looking for. Now, how can I use my chart? I'm not using the 68, 95, 99.7 rule. That would be a different way to do it. Remember, there's 2 ways to do this, and you have to do it the way that I ask you to do it. And so this time we're using the z-score. And so if I go back to my z-score table, I look at -2 right here, -2.0, and I go over and I get 2.28. Now, these numbers in here, you'll notice that they get bigger and bigger. The percentages get bigger and bigger and bigger and bigger and bigger and bigger. They don't, and at 0, what do you get? You get 50, because if your z-score is 0, you're at the mean. 50% of your data is to the left of the mean, right? 50% is above it, 50% is below it. So these percentile numbers are slightly different. I'm not giving you percentages between 2 values. I'm giving you percentages to the left of the value. So if you've got -2 right here, okay, you've got -2 right there, that value is 2.28, and so I take that value 2.28, and that's my percentage, okay, that's my percentage of -2. Z of -2 gives me a percentage, let me call it something different like P, all right, gives me a percentage of 2.28, and that is a percentage. So 2.28%, very little percent of the data lies to the left. Now this graph looks like a lot more than 2.2% of the area, but again, I'm not a perfect artist, so don't worry about that part of it. But what you do need to know is you need to know how to read that table. That's all you need to do, okay? Now, obviously, for different problems, all right, it's not quite that easy. So let's go to part C here for the same problem. Part C, find the percentage of data that is more than 47. Okay, so again, our data point is based off this situation. Now I'm looking at a number here, 47, but where do I want to go? Where am I looking between what? I'm looking to this side of the data now. I'm looking to the right of the data. So when I go to do this, I still need to calculate the z-score. I take 47 minus 50 all over 5. So I get -3 over 5, which is -0.6. Use your calculator for that, right? Simple enough. Now I go to my data set, okay, which again is given to you, and I look at negative 0.60. Here's negative 0.60. Negative 0.60 gives me what? Gives me a 27.43 percentile or percentage. All right, so what does that do for me? I get 20, I forgot the number already. I got 27.43. Okay, so P is 27.43%. So is that my answer? All right, I can't hear you, but no, it's not my answer. What does that represent? 27.43, your z-score table always represents the percentage of data to the left or below. So this is 27.43%. This data over here, how do I find the blue data? If this data to the left of 47 is this, how do I find this data? All right, well, all the data is 100%, so I just subtract. All right, so if I want to find it to the right, my percentage, the answer of my question, my percentage here, is take 100% and subtract 27.43%. Okay, again, use your calculator to do this for you, obviously. And so you end up with, that's 0.57, and then this is 82.57, not 82, 72. That's why I said use your calculator, and then I used my head, and that's what happens when you do that. You get 72.57% of the data is more than 47. So you got to see the question, more or less, or even in between, but usually if it's in between, we're asking you about the approximation rules. All right, and so that's the process. That's the way that you need to go about it. If you go back to your data, you go back to your worksheet, all right, starting with problem number 33, all right, starting with problem number 33, you've got problems that you can do with the z-scores, and then all of these, this worksheet 8 here, all of these guys go with this second half of 6.C, which is the z-score table, the standard scores. Okay, so do all these problems with the standard scores, all of these guys 1 through 6, and also do problems 33 through 36, and then all these guys down here will all be part of your z-score standard score homework. Okay, and you'll also have a MyMathLab obviously with the 6C, a second part with the standard scores. Okay, so hopefully that helps, and we will see you next time. Thanks.